Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Vitamath 45. Derive the direct formula for the length of the medians of a triangle and determine the length of the median through vertex B of a triangle having sides AB 15, BC 18, and CA 24. These data for this triangle are taken from Vitamath 44. So the angles A and C as well as B were already solved in that problem. And I will no longer solve them. You just verify from Vitamath 44 the values, and I will mention or copy or clip the values of these angles here. Also show that the medians of the triangle bisect the area of the triangle. So here is the triangle, and I will only derive the length of median through A, and from the result we will have the other formulas by deductive by following the pattern of the formula. So C is 15, AB is C is 15, BC is A and it is 18, and CA, which is B, is 24 units or 24 cm from that Vitamath problem. Then we have the median through A, we will call that MA, this point as D, and the angle here as theta. So a median, by the way, is a line segment drawn from one vertex to the midpoint of the opposite side. So if it is drawn from vertex A to the midpoint of the opposite side BC, then the foot of this median, which is denoted point D, will bisect the length of BC. So since BC is A, so this is A over 2, this is also A over 2. And we will call this angle theta. So this angle, the measure of this angle is 180 degrees minus theta. So from the figure, by just observing and not solving or deriving the formula for MA, one suggestion is you solve for angle C and angle B by cosine law. Then after solving for angle C, for example, then you can compute MA by cosine law in this triangle. So angle C considering the entire triangle. So from there, we can solve for the length of MA. After we solve for angle C by cosine law considering the entire triangle, then considering triangle ACD cosine law again, we can solve for MA. Or triangle ABD by cosine law, after solving for angle B, you can solve for MA. So by cosine law, MA square equals A over 2 quantity square plus B square minus 2 times A over 2B cosine of angle C, considering triangle ACD. You can also consider triangle ABD if you want. Then simplifying, MA square equals A square over 4 plus B square minus AB cosine of angle C. By cosine law again, considering the entire triangle ABC, C square equals A square plus B square minus 2AB cosine of angle C. Then solving for cosine angle C, it is equal to A square plus B square minus C square all over 2AB. We then substitute cosine C into this equation here. So MA square equals A square over 4 plus B square minus AB times cosine angle C, which is quantity A square plus B square minus C square over 2AB. We first cancel AB and simplify MA square equals A square over 4 plus B square minus quantity A square plus B square minus C square all over 2. Multiply both sides of this equation, or multiply everything here by 4. So 4MA square equals A square plus 4B square minus 2 times A square. So 2A square minus 2B square plus 2C square. Then combining like terms, 4B square minus 2B square is 2B square. Then plus 2C square, and A square minus 2A square is negative A square. Therefore, 4MA square equals 2B square plus 2C square minus A square. Finally, we extract the square root and we can now have MA. So MA equals square root of quantity 2 times B square plus C square, then close, minus A square divided by 2, because this is square root of 4 is 2. So that's the formula for the length of the median through vertex A. Then following this pattern, we can set up the length of median through B as 1/2 square root of 2 quantity A square plus C square minus B square. Then for median through C, it is equal to 1/2 square root of 2 quantity A square plus B square minus C square. So that's it for the derivation of the direct formula for the length of the median of a triangle. Then to show that the medians bisect the area of the triangle, so from this triangle here, we will first consider the triangle for finding the length of median through B, but later on. But we will use this triangle in showing that the medians bisect the area of the triangle. So same data, then this is the median through B. This would be 12 and 12. So area of triangle ACD from this triangle is 1/2 of MA times A over 2 sine of theta. Simplifying, area of triangle ACD is M sub A times A over 4 sine theta. Likewise, area of triangle ABD is 1/2 of MA times A over 2 sine of 180 degrees minus theta. And since sine of theta and sine of its supplement are equal, so this is the same as sine of theta. And if we simplify this, it is the same as that. So area of triangle ABD is MA sub times A over 4 sine of theta, which is equal to that. So we conclude that area of triangle ABD is equal to area of triangle ACD, and that verifies that the medians really bisect the area of the triangle. So that's the proof. And then considering this triangle here, use this formula, direct formula. By the way, from Vitamath 44, I already solved C, which is 38.625 degrees by cosine law, and angle A as 48.509 degrees from Vitamath 44. So assuming you cannot remember this formula for the direct length of angle bisector, but you know the definition of median rather, not the angle bisector. So if you know the definition of median, then we can solve this without the formula. So since we already know C and we already know A, this angle here and this angle here, we simply apply cosine law, because this is 12, that's theta, 180 degrees minus theta, 12 units, 12 cm, that's also 12. Then we can compute MB by cosine law of this triangle here, or in this triangle here. So MB square equals 12 square plus 15 square minus 2 times 12 times 15 cosine of angle A, and angle A is 48.509 degrees. So using your calculator, M sub B, or the median through B, is 11.42 cm. Likewise, in this triangle, MB square equals 12 square plus 18 square minus 2 times 12 times 18 cosine of this angle C here, which is 38.625 degrees. So using your calculator, we'll have MB, which is 11.42 cm also. Now for the area of the triangle, let's solve for angle theta, and the area is 1/2 of, for ABD, so imagine this is D, 1/2 of 12 times MB sine of theta. We already solved MB, so it's theta that should be solved by sine law, and if this triangle is drawn proportionately, then theta is acute. So it is safe to use sine law here. So 15 as to sine of theta equals MB as to sine of angle A. So 15 as to sine of theta equals MB, which is 11.42 as to sine of angle A, which is 48.509 degrees. So solving for theta, theta is 79.698 degrees. And the area of triangle ABD is 1/2 of 12 times MB, which is 11.42 sine of theta. So area of triangle ABD is 1/2 of 12 times 11.42 sine of 79.698 degrees. So area of triangle ABD is equal to 67.415 cm square, which is 1/2. This is 1/2 of the area of the original triangle from Vitamath 44. I asked for the area, and it was 134.83. So that proves that the medians really bisect the area of the triangle. So 1/2 of 134.83, this is the area of the triangle ABC with this data, with these sides, and you look at the area from Vitamath 45, Vitamath 44, and you can find there that the area is 134.83 cm square. You can also compute the area by Heron's formula here, but we ran out of space. That's why I'm just writing the area from Vitamath 44. Then, if you use the direct formula, MB is 1/2 of square root of 2, A is 18, so 18 square plus 15 square, close, then minus 24 square. Solving using this formula that we have just derived, so MB is 11.42 cm. So that's it, and I hope that you learned something new about geometry, plane geometry especially, for the length of the medians. So it's not the formula that matters, but it is the way of how to derive the formulas.